energy. It comes from the sun, the water, and the wind. In fact, it can be seen in the thunder and lightning of a storm. Modern civilizations are built on electric power, giving us energy to perform all sorts of tasks, at home, at work, and at play. Electricity has become indispensable, just like food, water, and shelter. We can no longer imagine a life without electricity.
Hello and welcome, my name is Susanna Hunt. NKT Cables and NKT Research have developed a superconducting cable which has been brought from the laboratory and into the real world. This is a project between several partners including industries, universities and electric utilities. For the last 100 years, electricity has been transported through cables made of copper and aluminium. Inside a copper conductor, the electrons bounce against each other. This creates resistance and heat. In the superconducting cable, the electrons connect together and form pairs. This removes the electrical resistance so the cable doesn't heat up. This material is called a high-temperature superconductor. The superconducting cable system has four main parts. The superconducting cable itself, termination in each end, a cooling system and a monitoring system that observes the status of all components. This exciting new cable technology has some advantages that I'll describe later. The disadvantages, however, is the need to keep the superconductor cold. Although they're called high-temperature superconductors, they must be cooled to about minus 200 degrees Celsius or 77 degrees above absolute zero temperature. The medium used in the NKT system is liquid nitrogen, which is cheap and exists all around us. This cold liquid nitrogen is circulated through the center of the cable to keep it cold. The superconductors themselves are in form of tapes from another NKT company, Nordic Superconductor Technologies, or NST. Outside the tapes there's a layer of thermal insulation with metallic foils called super insulation. Outside all this, there's electrical insulation and protection layers. They're based on reliable elements and have been known to NKT for a long time. So who'll use such a cable? The electricity industry has become tough and competitive after deregulations in most corners of the world. HTS cables will help electrical network companies to live up to their new requirements of reduced cost and increased efficiency.
The Electrical Engineering Department at the Danish Technical University, DTU, have participated in the research of the superconducting cables. In the early spring of 2001, they tested the superconducting cables fabricated by NKT. This cable system is rated at a voltage of 36 kilovolts and a current of 2 kiloamps. It's designed to link two medium-sized transformer stations in a city environment and can transport a power of 100 megawatts.
The superconducting cable is much lighter, and the superconducting cable is more environmentally friendly. And then there are the technology and physics behind the superconducting cable, which is much more advanced than in a conventional cable. You have to work with vacuum, and you have to work with electrical insulation, you have to work with very high currents, you have to work with cold temperatures. So this has been a very big challenge and also very big satisfaction to work with, I think.
A tape like this, when it's cooled down, it can take more than 50 amps. One of the greatest milestones in a project like this is the invention of how to make wires out from powder.
I think this cable is really a success.
Superconducting cables can offer the advantage of lower loss, lighter weight, and a more compact dimension. A set of two conventional cable systems that carry 200 megawatts will have losses described by this red curve. These two cables can be replaced by a single HTS cable with a lower loss at higher loads. The high performance of the superconducting materials means less material is required. For example, a 5-kilometer long power line would require approximately 36 cable drums of copper cable, each weighing 20 to 30,000 kilos. Because the HTS cable is lighter and more compact, it can be put onto only 7 to 8 drums of the same weight. These cables never get hot on the outside. This makes it possible to install cables in some soil conditions where normal cables would overheat. In many cities, it's more economical to transport electricity at the 30 to 50 kilovolt level. One example is the Copenhagen Energies 36 kilovolt 1.8 kiloamp cable systems in central Copenhagen. Now we'll see the installation of the first HTS cable system in the public utility network.
The first installation of an HTS cable system in a public network took place in February of 2001 in a substation that delivers electricity to approximately 50,000 residents on the island of Amager, just outside Copenhagen.
At 8 o'clock this morning we started to load the truck at DTU Institute, and then we drew the cable to the substation at Amager and start to pull the cable in position, and we finished, I think, about 11:30. At that time the cable was pulled into position, and we and this afternoon we start to install the end termination.
The purpose of testing is to prove that the superconductor is able to withstand the normal condition in an electrical network. In our minds, the benefits could be a cheaper solution in connecting high voltage grids with the suppliers to benefit the customers. In case the superconductor fails, there is no disruption for the customer. The conventional busbar coupler will take the load instead. There are other aspects in using superconductors in various components in the electrical grid where we could get a cheaper, smaller, more convenient component than used at the moment.
So NKT has installed the first complete full-scale HTS cable system in a public utility. So don't be surprised if one day you get cold and clean electricity delivered through a superconducting cable near you.
This installation has been a great success for us. We have now managed to bring the superconducting cable from the institute out in the real life. This has been a great milestone for us to reach this point.